Hi Twitch, and welcome back. Back here today, changing it up a little bit. So we just spoke with the Amazon EKS team. We're now here to talk with the Amazon Neptune team. I have Brad here, Principal Product Manager for Amazon Neptune. Brad, thank you so much for joining me today.
Yeah, great to be here, Abby. Really appreciate it.
So you guys launched last week and generally available. Here today with some live demo and question asking action. Super excited. Can you tell us a little bit about what you launched last week?
Yeah, so we launched the general availability of Amazon Neptune. Amazon Neptune is a fast, fully managed graph database service that supports both property graph with the Apache Tinkerpop and the Gremlin language for imperative traversals, and then it also supports the W3C standards of RDF and Sparkle 1.1.
So for those of us that are less familiar with graph databases, can you give us a little bit of an overview on what a graph database is?
Yeah, so graphs turn out to be a really important data structure. And so we really think about it in terms of connected data. So what we saw was that people needed to process highly connected data. And this is characterized by data that is changing very quickly. It's heterogeneous in terms of the data types and the attributes. But really, most importantly, the value and applications over it is in the relationship. So if you think social networking or recommendation engines or knowledge graphs, so those are kind of graph application spaces. And so Neptune is really optimized to efficiently process graph traversals and graph queries.
So what are some reasons that customers might be using a graph database or something like Neptune?
Well, we really are focusing on, there's 6 major graph use cases. There's a number of other ones, but the 6 that we're primarily targeting for the initial Neptune launch are social networks. And I think everyone generally has a good sense of social networks. Recommendations, so product recommendations. We ran a preview for Neptune, which was announced at last year's reInvent conference, which was really very popular, and we were quite impressed by the breadth of customer use cases that they tried out. So people did things like in-game recommendations. So how can I present offers to customers to help them in-game to make changes? So recommendations. Knowledge graphs, this is a technique where people use a graph model to represent information, and they use it to drive information retrieval. So we had customers like Siemens using knowledge graphs to help with industrial applications. Fraud is a classic graph use case. And then life sciences and network topologies, really.
So I think something that's a little bit more personal for me on this one is that graph databases are historically not super easy to work with. What are some ways that with Neptune we've been able to kind of make that a little bit easier for you to get the benefits of a graph database, so being able to make connections between lots of different pieces of information, but make it a little bit easier to run operationally?
Yeah, I mean, it's one of the things that we heard from a lot of customers is that they'd tried out a graph database and it had been really successful, so they'd done a proof of concept or a POC, and they liked the APIs, they thought it was easy to solve their problem, but when they scaled it up and they tried to put it into production, they ran into challenges like you expressed. They couldn't get high availability or encryption at rest without doing enterprise licensing, those kinds of things. And then the other thing that we saw that really struck us as well is that there's a lot of different options that customers have for both the property graph model and the resource description framework or the RDF model. But there tends to be a really strong performance bias towards one or the other. So if you choose an RDF solution, you're not going to get great property graph performance or vice versa. So that was sort of the context that we built Neptune on. And Neptune is designed for graph use cases that need high throughput query answering with very low latency. And so it's a fully managed service, so you don't have to do any of the operational aspects. You can configure high availability at all levels, whether you provision the smallest instance or the largest. And the fully managed experience is designed to be very consistent with that you've come to expect from instance-based database services at AWS.
So I know that a lot of the common questions that come up around things like launches are, what about things like CloudFormation and extra regions and backups and stuff like that? Can you talk a little bit about what Neptune shipped with? And because you mentioned fully managed, and I think that's a big piece that goes into fully managed.
Yeah, so we're super happy that we launched with CloudFormation support at GA on day 1. We launched in 4 different regions. So we launched in US East Northern Virginia, US East Ohio, US West Oregon, and EU Ireland. And so we're now available in those regions. As you mentioned, it is a fully managed instance-based database service. So you don't have to worry about patching. You can use the console SDKs or APIs to back up. You can provision, Neptune uses a cluster-based model. So you can choose to provision the architectures of your cluster. You can specify the failover order and perform those kinds of operations on it.
So most exciting part, I believe you have a demo for us. So can you show us how it works?
Absolutely. Let's stop talking and let's take a look.
It's the best part. This is the best answer, is stop talking, start doing.
So the first thing I wanted to show everybody was just how you can start a Neptune instance. So if we look over here, and I think we're showing our console here.
Yep.
So what I can do is I'm just in the console here, and I can just start with Neptune, and I see it's showing up there. And the first thing I do is I launch a Neptune instance. So we talked about Neptune is an instance-based database service. I can choose my instance type here. I'm going to choose an R4. We're supporting the R4 family at launch. And to enable high availability, all I have to do is leave this box checked. And that's it. And now I have multi-region high availability for my graph database.
That, by the way, is probably the most anticlimactic high availability process that I've ever seen. It was just a box.
Well, that's what you want, right? you want high availability that you don't have to worry about.
I'm not complaining, but it's definitely the most anticlimactic, and I love it.
So after that, we have a couple of different options. We can choose which VPC we want to deploy it in. We can choose to put it in an existing security group or have it create a new security group. If we want to choose a different cluster identifier, we can do that. We have some parameter groups. We also support IAM-based authentication for access to the endpoints. And so when you provision an instance of Neptune, you get both a Gremlin WebSocket server, and we're supporting Apache Tinkerpop 3.3.2 currently, and then you get a REST endpoint that implements the Sparkle 1.1 protocol. And so you can choose to have IAM authentication on that just by selecting enable that, and you can then later configure it within your cluster. Same kinds of things for encryption. So if you have a use case where you want to have the integrity of encryption at rest, you can do that using KMS or customer managed keys with Amazon's key management service. And then again, what I talked about, failover, you can specify the preference, the backup, maintenance period. So all of these kinds of fully managed features are what you can do here through the console. And I'm just going to go ahead and do that. And we're going to go ahead and spin up an instance, and we'll come back and take a look at that. Now, you don't have to use the console to do this. You can also use the CLI or SDKs. And so here's just an example of the documentation for the Neptune class in the Java SDK. And then we're going to be releasing some new documentation for CloudFormation support to help customers use CloudFormation.
Sneak peek.
To be able to provision Neptune instances. And so here's a quick look at what this page looks like. And then here's an example of the CloudFormation in the designer. So here's one of the templates that we'll be shipping that you can create a Neptune instance inside of a VPC, provision an EC2 instance, and access it within your cluster. And then if we want to take a look at that, in the designer, here's what it looks like as well. And so those are sort of how you get to creating an instance, which is really cool, but it's really just the first step of the journey. So what people really want to do is build graph database applications.
I have to put data in my graph database. Yeah.
Enough already. Show me the application. So the first thing is, how do I get data in there? Well, there's a lot of different ways. So we support a bulk load capability. So each Neptune instance has a REST endpoint that you can post JSON documents, where the JSON documents are specifications for loads, and they specify an S3 bucket, and then different types of data. So for property graph, we support a CSV-based serialization, and for RDF, we support 4 different RDF graph serializations. So we support Turtle, N-triple, N-quads, and RDF XML. For Tinkerpop or property graph applications, there's a really handy open source guide from someone named Kelvin Lawrence who's put together a guide to getting started with Gremlin.
Nice.
And so Gremlin is an open source framework from Apache Tinkerpop for property graphs. In this case, he uses an airport code example to be able to show you and teach you how to use the language. So if you look very simply, this statement g.v, so graph.vertex, has label airport and show me the values for the code. And so if you look through this, and I think the link is in the chat, you can see an example of how to do that. Now, he's got some data that he's made available here for the air routes data. So this has airports, routes between them, flights, and carriers. And we've also made available on the AWS Labs some tooling to allow you to convert data from GraphML, which is a XML-based serialization for graphs, into the CSV format that Neptune supports for property graph. And so you can see here is an example of the GitHub site. Here's the example of the GraphML to CSV. And so we're going to actually go take a look at that now. So the first thing I've done here, and I'll show you a little bit more in detail, but this is my Cloud9 instance. So this is my sort of cloud-based developer IDE that I'm using.
Cloud9.
Sneak for Cloud9. It's really super easy to demo from.
Yeah.
And so I found it at a summit about 6 months ago, and I really
Totally
enjoyed it ever
Cloud9
since.
convert now.
So the first thing I'm going to do is actually just execute a curl command and download that file. And then, so I've downloaded the GraphML file. And then I'm going to go through and execute the Python script from the GitHub repository. And what's going to produce are two different files. The first is a set of all the nodes in CSV format and a set of all the edges. And so you can see I've basically taken the standard serialization from a very popular example. Now I've got two CSV files. I'm ready to put them into my S3 bucket and launch the Neptune load command. So let's go take a look at that. So I'm going to minimize my console here, and I'll show you what the load command looks like. So here you can see a little bit more about Cloud9. So this is an example of what a load command looks like. You can see it's a very straightforward curl expression. I'm basically posting this JSON document. It specifies the S3 bucket that I want to read from. Now you can choose to specify a single file, in which case we'll load just that file, or you can specify a folder endpoint in your bucket. And if you specify a folder endpoint, we'll load all of the files in that folder, and you can call that endpoint multiple times, and we'll load new files for you. You also can specify the format. For property graph, that's just CSV. For RDF graphs, you can use the turtle format. The region, and then we have some parameters about how it works, if there's an error, for so on and so forth. So that's how you kind of get data loaded into Neptune. But let's look at how you'd access the graph. And so the first thing we're going to do is I've downloaded Apache Tinkerpop's console. So they have a Java-based console. It's a REPL-style console. I've downloaded the one from the Tinkerpop site. And I've set it up on my server here. And in there is a file. You can see the hierarchy here on the left. There's a configuration directory. And they have these YAML files. And the YAML files specify different endpoint WebSocket server configurations that we can use to connect to. And so here I've taken the remote YAML file that ships with Apache Tinkerpop, and I've just made a couple of small changes. I've put in a particular host here that we're using to connect to it. And what I'm going to do now is actually just go ahead and connect to that server. So I've started off my Gremlin Tinkerpop server. I'll bring it up here so people can see it. And this command is just basically saying, okay, I want to go Tinkerpop console and connect to my Neptune instance. Now this is a Neptune instance that I provisioned and is running in my VPC, and the same VPC as the EC2 instance for Cloud9. And then I'm going to say, hey, console, send all of the commands to the remote server that I just configured. And so the first thing I'll do is just do a g.v, and that's going to just say, hey, I've got some data in there. Well, so that's just kind of the mechanism. But let's talk about what it is you might actually want to do. And so one of the things that happens pretty regularly is fraud applications. And this is a really basic fraud example. And one of the common things that happens with frauds is they're sort of identity rings. And these are basically where groups of individuals are colluding, and they're opening multiple accounts with sometimes the same or different financial institutions. And they share a little bit of information, and then they use all of these sets of accounts and the collusion to execute various different kinds of financial fraud, insurance fraud, so on and so forth. So this is a very basic example of 4 individuals that have several different types of financial accounts. They got bank accounts, credit cards, loans, so on. And then they also have those accounts have associated with them some identifying information. So there's national IDs, there's social security numbers, there's telephone numbers, there's emails, so on and so forth. So I want to then load this information into my graph database, and I want to write some gremlin traversals to help me find these fraud rings. So
the goal here, by the way, is that you're using pieces of information that aren't directly connected to make connections. So that I'm not just saying, okay, well, that person's never going to be directly linked to fraud. So you're basically using a graph database to connect lots of kind of semi-connected pieces of data to traverse one relationship to get to the second one.
That's right. So what this example has done is people have created these accounts, and they've put various different pieces of information, but they haven't been perfect, right? So they haven't, they're reusing forms of the address, they're reusing forms of the telephone. So we're going to use those properties to write some graph traversals to help us try and find that. So that's absolutely right.
Another example would be if I'm friends with Brad and Brad's friends with Amit, then perhaps I might like to be friends with Amit.
That's right, and that's actually, that technique is formally called triadic closure.
Yeah.
And basically graphs or triangles are the smallest fully connected subgraphs. And so by finding triangles that you can complete by adding an edge is a really sort of key kind of recommendation sort of approach, or it's how people get started with those kinds of applications.
So if you're just joining us on Twitch and you've been one of the people saying that you weren't quite sure what a graph database is, I just gave a really simple example. But the fraud example, I think, is a step further than that, which is how can I use the things that I know that aren't directly connected to find out another piece of information that I can use because I know some of those other information. So it's kind of like, it's like being a detective, honestly. But like with data instead.
There's a lots of different, but really it's any time that you have data where it's the relationships that matter. So
right.
If your application is about finding friends of someone, if it's about looking at purchase histories and making associations through chains of purchase histories, if it's about saying, making knowledge recommendations. So Amazon Alexa is one of our GA launch customers. They're using Neptune as part of a set of technologies for building knowledge graphs. And so, fraud we're talking about here, life sciences, it turns out that lots of things in life sciences have a natural network representation. So things like protein pathways, we're going to look at some disease genome associations here. Those are all cases where it's really traversing that's the important thing, and graph databases are designed specifically to do that.
Right. So I've a couple questions from Twitch. I know that we talked about different the format of data basically, and then if I use Tinkerpop, then I could maybe export from one Apache Tinkerpop to another database. So how can I both move my data? How can I move my data into Neptune? So how can I migrate from something else and start using Neptune? Is that possible as long as I'm using the same format? Is that okay?
Yeah, absolutely. So we support for property graphs. We support a CSV-based serialization. So what you need to do is you either need to export your existing system into GraphML, and then you can use that Python tool that we've released on GitHub to convert GraphML into the CSV file. So that's one option. Or for many customers that are either moving from another graph database or sometimes moving from a relational database or other systems, they basically write a relatively straightforward ETL job they decide what they want their nodes to be, and then they export their nodes and the node properties in a single CSV file. And then they decide the edges, and they export the edges and edge properties into a CSV file. And they're able to load that and to make it, to load it in. Now for RDF graphs, RDF has a standard serialization. So many customers will bring us RDF data, and we support RDF 1.1. So any data that you can serialize in RDF 1.1 will load into Neptune relatively easily.
If you're following along on Twitch, by the way, some of these examples that Brad has mentioned around the Python library and the examples on the AWS samples GitHub page, links have been posted in the chat. So should be links for you to follow if you want to click on any of these tools that Brad's been talking about.
Cool. Yeah,
awesome.
Fantastic.
Cool.
So,
I derailed the demo, by the way. But
no, that's fine. It's an important question. So this is going back to their fraud demo, just to catch everybody up. So we have a fraud ring. We got multiple individuals that they've created multiple accounts, and we're trying to find places where they're sharing information. And so we can write a gremlin traversal to do that. And so here on my screen, you're seeing the gremlin traversal to find fraud rings at sort of an arbitrary depth here. And what we do is we start with an applicant. So if you'll remember, there were people that are applying for accounts, and that's where we start. And so we're going to say, find all the potential fraud rings for this applicant whose name is Terry Wilder. And what we're going to do is we're going to start with the applicant. We're going to go to the account, the credit account, and then we're going to find the different characteristics or the attributes associated with that. And then we're going to walk back up the graph and find other people that are reachable from there. And that's basically the sort of pseudo algorithm of what we're going to do. And we do that by doing this loop in Gremlin until the loop is finished. And we basically, what gets output is a list of candidates that are sharing the same identity information. So now I'm going to go ahead, and you'll recall I connected to my Gremlin instance. So I'm going to go ahead and drop this in. And I've run that against Neptune. And I can see that in this case, there's 5 people, including Terry, and 4 additional people that share some kind of account information. So is it definitive? No, but it's a good starting point. And if you're looking, if you're imagining a large system where there's lots of different sets of information, sets of accounts to sort through, this will give you a really good way to quickly traverse and find places that you may want to look in more detail.
So we can, and we also caught a criminal in this example, which is bonus points for that. So I have a question from Twitch that said, how do you handle extremely high load databases with large data sets? So how would a failure of master write be handled also? So 2-part question. So 1, is it okay to have extremely large data sets? And then 2, how does a master write failure get handled?
Yeah, we didn't really talk a lot about the underlying architecture, but that's really part of what makes Neptune enables the fully managed experience. And so Neptune itself is built on top of a distributed cloud-native storage layer, which is technology that's shared with other instance-based database services at AWS. And that storage layer supports a segment size of up to 64 terabytes. And so in our testing, that translates into a graph of somewhere between 100 billion and 200 billion nodes, edges, and properties, or triples. So you can certainly get to that sort of data scale size. And then the underlying architecture is that there's a write master with up to 15 different low latency read replicas. So in the event of a failure of the write master, if you've provisioned a read replica, you'll have a failover, in which case the read replica will be promoted to the write master. And if you don't have a read replica, a new one will be created for you.
I think that's part of high availability as a managed service too, right? Is that there's always backup options in case something isn't working quite the way that you expected. So by saying it's fully managed and highly available, there's things like replicas that you can fail over to and then promote.
Absolutely, although you do need to sort of think about your architecture and make sure that, if your application needs a fast failover, make sure that you provision a read replica, because that's going to make you, if we have to start a new instance for you when there's a failure, it's going to take a little bit longer. So you do need to, there is a sort of the shared responsibility concept of thinking about your cluster, and we enable you to build those kinds of configurations.
So I've seen a couple times from Twitch questions around sharding. Does Neptune require sharding, or is that something that I should or need to do with Neptune?
No, so Neptune is really designed, so when we talk to customers, what they told us is that they really wanted a graph database that could serve these sort of interactive graph queries and provide high throughput and very low latency query answering. And so we sort of architected the Neptune to be able to meet that use case need. So we do use a distributed storage layer underneath, but you don't have to shard or partition your data. You also don't have to create indices over your data. So Neptune uses an indexing scheme that auto-indexes it for you. So you're going to be able to get good graph traversal performance without having to decide, do I need to index this particular property? Do I need to index this particular attribute?
I would say that that's another one of those, I guess Amazon would call it the undifferentiated heavy lifting, but creating indices and maintaining them and then sharding a database is not insignificant. It's a pretty big operational project to take on. Like if you don't start with a sharded database, what happens when you have to go back and shard what you already have? So not necessary in Neptune though. And no indices, no sharding.
That's right. Now, the way I think about it is we want to basically reduce that time to graph, right? We want to make it, your time to starting actually writing a graph application, to get that to almost to 0. So, we're not quite there yet, but I think we've come a long way in terms of what Neptune provides as a fully managed capability.
I think that should be your next sticker for Neptune is reduce time to graph.
Getting to 0 for getting to graph. So.
I have another question. Does Neptune support data encryption at rest? So obviously, if I'm storing a bunch of data and I want to get insights on my customers, how can I make sure that my data is encrypted?
Yeah, so again, it's one of those things that we shipped with at GA, and so you can choose when you provision an instance, you can choose to encrypt it at rest using your own key. So you can use a key that you're managing through the Amazon Key Management Service, or KMS.
Awesome. So yes to encryption. You can use KMS, which is already in AWS, to help you handle that. For the people that just asked if Neptune was GA, yes, announced last week. We're here with Brad. We're demoing. We're asking questions. We're answering questions. But GA last week, available in a couple different regions, and now it's live demo time. So yes to GA. And for the people asking what is Neptune, if you're just joining us, Neptune is a managed graph database that we announced in GA last week. So do things like traverse relationships to find out new pieces of information that, like,
absolutely.
Brad and I are both committing credit card fraud, and you could find that because we both frequented the same place and did the same thing. Mm-hmm. Awesome. There's links in there. There's a blog post out. We've posted a couple links to the documentation available, and someone just listed the whole region, so North Virginia, Ohio, Oregon, and Ireland.
That's right.
The moderators are on top of their game today.
Fantastic. They're a great team. They're a great team.
Great team of moderators.
So I wanted to switch over as well and just show a couple other things.
Yeah.
So for people that are interested in more about the property graph gremlin example, we also have a GitHub site on Amazon samples, AWS samples with the Amazon Neptune samples. And in particular, there's currently a collaborative filtering example. So collaborative filtering is a technique that you can use to make recommendations. And so this has everything that you really need to get started. So it has an image of the data set, a small data set, how to load the data. It also has some sample queries. There's sort of a gaming theme here. So I would definitely encourage people to take a look at that, as a way to get started. And, we're really interested in seeing what you guys do with it. So if there are people out there who try something out and do something cool, we've had customers in the preview model global tax compliancy as a graph to help.
That's pretty cool.
Yeah, it's kind of a nifty application. In fact, the number of tax graph applications really is surprising me. But it's also, you also see fraud, you also see recommendations, social. But what customers do with graph is really, really very interesting.
I think it's incredibly powerful because, think about something like book recommendations, and how something that I liked a couple other books, and Brad liked this book and he likes the same book that I do sometimes, then maybe you recommend me a third book. And the things that you can do with it are everything from catching fraud to looking at genomes to recommending all the crappy books that I buy to read on planes. It's really incredibly powerful.
It is, and it's really part of it's a specialized purpose-built database that's designed for the relationships. And so, I think one of the things that we're seeing is customers wanting to build applications that span multiple different kinds of databases, and Neptune is really kind of a great fit for those pieces where you need to do those kinds of traversals, the recommendations, network topologies, network defense. All of these applications really have some really nice and strong graph components.
That's awesome. And the link, by the way, to the Neptune samples that Brad just mentioned is already in Twitch chat. So if you're following along with us, you can see everything that he's doing on his screen is at that link.
Fantastic.
Cool.
Fantastic. And so the last thing I really wanted to show before we kind of go through more questions is, we also support the RDF Sparkle data sets. And so, customers often ask, should I use Property Graph or should I use RDF? And, you can do almost any application with either model. What we find is that customers that are coming from a sort of property graph, a relational database background, often find property graph sort of a more natural traversal. So if they're thinking about tables and row structures, thinking about nodes and nodes properties or edges and edge properties is a really natural fit for them. And then customers that want to reuse data sets that are publicly available, like DBpedia or Wikidata, or information that's published by the national health organizations, RDF provides a standard data serialization, so they can benefit from taking advantage of those kinds of data sets. And so this is an RDF example, and what I have here, much like my other example with Gremlin, I'll make that a little bit bigger, is that we have provisioned a Neptune instance. Again, it's sitting in my VPC, And I'm using that Sparkle 1.1 protocol endpoint. This is the RDF for J workbench. This is an Eclipse licensed open source workbench that you can use to connect to any Sparkle 1.1 endpoints, and not just Neptune, but others. And I've loaded a data set that has disease genome association. So this is published by one of the US national health organizations, and it's a catalog of research about diseases and what genomes they've been associated with through research. And I'm going to ask a Sparkle query. So this is a declarative graph query. And what I'm going to ask for is I want to find out about Alzheimer's disease, and I want to find out all of the genes that are associated with Alzheimer's that have this score greater than 0.29. So Sparkle expresses graph queries as a triple pattern, so subject to predicate and object. And so these are all represent different triple patterns. And so this question mark here shows you is a shared variable. So basically, find me a disease that's called Alzheimer's. And then I'm going to reuse that variable in another triple pattern. That's how I effectively do this join operation that we talked about in the traversal. I'm going to pull back the genes. I'm also going to grab this score attribute, and I'm going to apply a filter on the bottom and then just do it order by. So if you are familiar with SQL, Sparkle will look somewhat similar, although there's some important differences. And then I'm just going to go ahead and execute that, and I can see here the 6 different genes that are associated with Alzheimer's disease in this data set. And I can choose if I want to go browse, and I can see more information about that. So that's a quick example of looking at from the Sparkle side. And so we have customers in preview doing both RDF and Sparkle and Property Graph. Many organizations have use cases for both. And so we're really happy as a product that we're able to provide a first-class sort of optimized query execution experience with both stacks.
So lots of stuff kind of coming out of the gate, right? So things like backups and CloudFormation, a couple of different regions can access your data in the way that works for you, whether it's with a workbench or through another tool.
That's right. Right out of the gate, we have four different regions that we talked about. We have console, we have CLI, we have SDK across all the language bindings. We have CloudFormation support. And so really, Neptune is really ready for you to start using to build graph applications with.
That's awesome. Okay, well, Brad, it's been really great today. Thank you for demoing Neptune for us. If you've been following along in Twitch chat, check out some of those links, so the samples and the GitHub page and the documentation page, and there's a what's new blog post. So tons of options out there. Learn a little bit, give it a try. Thanks to Brad, and then if you have questions, keep passing them on through Twitch chat. I think the moderators will hang out for a couple minutes and answer the rest of your questions. So thank you for joining us today. It's been an exciting day of live stream launch announcements, and we will see you another time very soon on twitch.tv/AWS. If you missed this broadcast, you can catch the video on the AWS Twitch page.
Thanks, everybody.
Thank you.